Okay, you just went through notes, writing equations in two variables. Now we are going to do worksheet 6 together. This is difficult. You have to kind of take this piece by piece, step by step. So let's go through this together. You may need to pause when we get down to some of the graphs to make sure and draw them on your own, okay? Everything I'm writing down, you should be writing down. Okay, so this is worksheet 6. We are, write the formula for the following. Tell what each variable represents. Try to identify which variable depends on which. Okay, the area of a rectangle with a length of 6 inches. Okay, so we're going to write the formula first. The area of a rectangle is length times width. And it says it has a width of 6 inches. So we would substitute in 6 for the width, okay? We're not solving anything here, guys. We're trying to figure out which is the dependent and which is the independent. Remember that if something is independent, adults, think of adults. Adults are independent. They can do what they want, okay? Dependent is more like you're the student, you're a child, so you depend on your parents for money. You depend on your parents to get you to school every day or to get you to sports, okay? So which one depends on the other, okay? The area, the answer to this, the area is the dependent. The answer is going to depend on the width. Okay, so the dependent is the area. The independent variable would be the width. Let's look at the next one. The area of a triangle. Formula, 1/2 base times height. It says the base is 7. Okay. So again, your answer or your area is dependent on what? It's dependent on the, it's dependent on what we throw in for the height, okay? So the dependent depends on the answer or what we substitute in for height. Okay. I think I put this one in wrong. The length was 6. Sorry, the length was 6. The width is the independent. Okay, and then the base is 7. The independent is the height. Okay, sorry if I confused you there for a second. Okay, next section, we are going to tell whether the ordered pair is a solution, okay? Remember ordered pairs, when you go to plot a number, this is always your x, this is always your y. X comes before y, right? When you sing the alphabet, W, X, Y, Z. So we are plugging in these ordered pairs into this equation. Y is 4. Bring down your 4. X is 0. A number next to a letter means multiply. So 4. 4 times 0 is 0. Okay? Tell whether the ordered pair is a solution. No, 4 does not equal 0. 0, 4 is not a solution. Let's look at number 4. I want you to start by labeling. This is your X, this is your Y. Plug in 2 for the X. Plug in 6 for your Y. Go ahead and plug it in and let's see what you get. 3 times 2 is 6. So yes, this is a solution. This is very similar to what we did the other day. Is it a solution? This time we've got 2 numbers that we're plugging in, an X and a Y. Number 5, here's my X, here's my 5, or here's my Y. Plug in 3 for the X, plug in 5 for the Y. Go ahead and solve. Let's see what you get. Plugging in 5 for Y, 3 for x. 15 minus 10 is 5. So yes, that is a solution. And then finish up by doing number 6. Plug in your x, plug in your y, and see if this is a solution. No, it is not. Okay, starting with number 7. Here's where you may have to pause if I go too quickly. Write and graph an equation in 2 variables that show the relationship between the time and distance traveled. An iceberg moves 2 meters every 3 hours, okay? Every 2 meters, it travels 3 hours. So we're going to write or show the relationship between time and distance. So down here is our time, and it's in hours. And then along the y-axis is our distance, and our distance is in meters. Let's go ahead and put a title on our graph. We're talking about an iceberg. So we've got all of our titles on our graph. So we have time, and we have distance or movement. I'm going to write distance, but I'm also going to write movement. So an iceberg moves 2 meters every 3 hours. Okay, so let's start with always 0, 0. That's the easiest one to always start with. Okay, after 0 hours, it has moved 0 distance, right? Okay, every 3 hours. So we're doing 3, 6, 9. Every 3 hours, it moves 2 meters. So 2, 4, 6. Okay, so there's our little XY chart. When we do this, we've now made ordered pairs. 0, 0, 3, 2, 6, 4, and 9, 6. This is my X, this is my Y. X down here is time, which is on this side. So at 0, 0, we're right here. The first one, at 3 hours, 1, 2, 3, it's at 2 meters, so 1, 2. At 6 hours, 3, 4, 5, 6, it's at 4 meters. And at 9 hours, I'm off the grid, I'm at 6 meters. Oops. It would be off. It would be up here. Okay. Okay, so do we see how we use that chart to help us graph this point? And then we can connect this and put arrows at the bottom of it. Okay. Alrighty. Let's do another one. An elevator rises 5 stories every 6 seconds. Okay, an elevator rises 5 stories every 6 seconds. So again, we have time and distance. Our time is in seconds. Our distance is in stories. Okay. Okay, down here on the x-axis, we have time in seconds. This graph is not the best. Over here, we have distance, and this is stories. How quickly this elevator is rising. The elevator is rising 5 stories. It's going up 5 levels every 6 seconds. Always easy peasy, start with 0, 0. And ignore this, that is from something else. Ignore that, please. It's just kind of helping you figure out the lines because they're fuzzy. Okay, every 6 seconds. So 6 seconds, 12 seconds, 18 seconds, 24 seconds. It rises 5 floors or 5 stories, 5, 10, 15, 20. And then we can use these. These are now our ordered pair that we're going to get ready and graph. That last one I'm not going to graph because it's not on the chart. Okay, we're going to start at 0, 0. After 6 seconds, we're at 5 stories. So find 6 and up 5. After 12 seconds, we are at 10 stories. Let's see, 12, 10. And after 18, we are at 15. 18, 15. I think I got that right. It's hard to see. And then we can draw our line and make arrows. And let's put a title on this graph as well. We're just going to call it an elevator. Nothing too fancy. I'll put elevator speed. Okay, let's look at number 9. Again, time and distance. Let's look what we're looking at. Time is in seconds, distance is in feet, and that's how we're going to label our graph. We're talking about a turtle speed this time, so we can put a title on our graph. We have a time in seconds, distance is in feet. Okay, we always should start with 0, 0. At 0 seconds, it's gone 0 feet. Every 5 seconds, 5, 10, 15 is what this chart goes to. The turtle moves 2 feet. 2, 4, 6. Okay, and now we've got our ordered pairs. 0, 0, 5, 2, 10, 4, and 15, 6. Starting with 0, 0. After 5 seconds, it's moved 2 feet. 10 seconds, 4 feet. 15 seconds, 6 feet. Okay, so again, we always have, it'll tell you how to label your chart, time and distance, and then you just have to determine which is the time and which is the distance. Okay, which is the time, which is the distance. Okay, again, yours should be looking just like mine. All right, let's look at this last one, number 10. A cheese pizza cost $8. Additional toppings are $2 each. They always get you with the toppings. Write and graph an equation into variables that represents the total cost of the pizza. Look at this chart. Okay. Number of toppings. 0 toppings. Well, so it's just a cheese pizza. It's $8, right? So the cost is $8. Okay, what if there's 1 topping? Remember, toppings are $2 each. So it's $8 for the cheese pizza. It is $2 per topping. So plus $2, $10 for the pizza. What if I do 2 toppings? 2 toppings, $2 a piece is $4 additional dollars. So $8 for the pizza plus $4 in additional toppings is $12. 8 plus 4 is 9, 10, 11, 12. What about 3 toppings? They are $2 a piece times 3 toppings. That's an additional $6. $8 for the cheese pizza plus $6 in toppings. 8 plus 6 is 14. What about 4 toppings? They are $2 a piece. 4 extra toppings, that's an extra $8. $8 for the pizza, $8 for the topping. That's $16 for the pizza. Okay, so now we're going to build a chart off of these. Okay, obviously again the cost of the pizza depends on the number of toppings. So always try to be thinking about which depends on what. Okay, so here we can say we're looking at the number of toppings and the cost for the pizza. Okay, so for 0 toppings, it was $8. Oops, 0 toppings, $8. For 1 topping, it was $10. For 2 toppings, it was $12. For 3 toppings, it was $14. And finally, for four toppings, it was $16. And these become our ordered pair: 0, 8, 1, 10, 2, 12. Don't know what I just pushed. 3, 14, and 4, 16. Okay. This is number of toppings on the bottom. This is the cost. And this is pizza toppings. You should have all 3 labeled. Let's make our chart. 0 toppings is $8. 5, 6, 7, 8. It is hard to read. 1 topping is $10. If this is 8, 9, 10. At 2 toppings, it is $12. 3 toppings, it is $14. This only goes to 15. I'm going to put 1 more up there. And then at 4 toppings, it is $16. This is the price of the pizza. Okay, periods 2 and 3, Gen Ed, kiddos. Listen, you've done the notes. I helped you with worksheet 6. Yesterday, when I was here, remember that we had a graded worksheet. Okay, it was worksheet 5, solutions to equations on the front. There was 8 of them. You turned it over, and then there were 8 solving 2-step equations. That should be in the tray. Okay, that was a graded homework assignment. If that is not finished, be sure to get it out now, finish it, and get it in the correct tray by the end of the period. Okay.